start with the topic resolution. Now what is this resolution? Resolution means separation. Separation of the peaks on the chromatogram means what? Resolution. Now what is this chromatogram? This chromatogram, it is a graph we obtain from the detector response versus time. Okay, we will obtain chromatogram like this. Okay, now what is the resolution? Resolution means separation of the two components on the chromatogram. The extent to which the separation of these two components takes place on the chromatogram is called as a resolution. Now this graph gives the good separation. Okay. Means we obtain the better resolution by this type of graph. If we obtain the graph like this, this is also detector response versus time. Okay. Now this is, we obtain the merge band. Okay. Merge peaks on the chromatogram, and in this graph we obtain the well separated peak. When we get such type of well separated peaks, means the resolution is better in that compound. Okay, we get a well separated bands. And when we obtain the merge band, means these are the merge peaks on the chromatogram. This is not the good separation. Therefore, resolution is very less in this type of graph. Now we will see the one equation for resolution. Firstly, see one graph. Okay. If we obtain the peak like this, then we will draw the tangent on this line as we have studied in the plate theory. By drawing the tangent, okay, this is what? Width of the peak. Okay, this area is width of the peak. And when we draw one line here, this is what? Height of the peak. And at half height, we get a W half. Okay. Now we will derive one equation. Now this resolution is given by the RS. The equation will be delta Z upon WA upon 2 plus WB upon 2. What is this? This half of the peak width. Okay. What is this delta Z? Delta Z is equal to retention time of B component minus retention time of A component. Means this delta Z is the difference in the retention time of the two components. Now this equation will, when we rearrange this equation, we get RS is equal to delta Z upon WA plus WB upon 2. We are taking 2 as a common. Then RS is equal to, when we rearrange this equation, 2 will be go on the delta Z side. We obtain the equation like this. Now we put the value of this delta Z here. We get RS is equal to 2 into TRB minus TRA upon WA plus WB. Okay, this is the equation for the RS. Now what is this TRA? This is the retention time of, our graph is detector response versus time. This is what? Height of the peak. Here we get retention time of 1. If you get 2 plots on this chromatogram, then this height will be RT2. Okay. What is this RS? RS is the resolution. It is given by delta Z upon WA upon 2 plus WB upon 2. When we rearrange the equation, we get 2Z upon WA plus WB. The value of delta Z is TRB minus TRA, means difference in retention time. Now this is given by, when we put this value of delta Z in this equation, we get, this is the last equation which is for the RS. Okay. Now we will consider one example of this resolution. What is that example? Now I will draw one graph for the 3 components. This is the detector response versus time. Now I have drawn 3 graphs on one line so that we can compare easily these 3 graphs. Now we will draw the baseline for each graph. this baseline is drawn on the tangent. Okay, firstly you have to draw the tangent, then draw this baseline. Now I will number this as A, this is B, and this is C. Now the RS resolution for one is 0.75. Resolution for this B graph is 1, and resolution for this C graph is 1.5. Now at the center of this peak we draw the one line. This line correspond to TR1, and this line correspond to TR2, means retention time 1 and retention time 2. Here are WA by 2 and here is WB by 2. This is the width of the peak and this is the half width of the peak. Okay, now we will compare this graph. When we get this graph of detector response versus the time, now see the A graph. In this A, we get in this A graph of chromatogram, we get the merge peaks. Due to this merge peak, the RS value will be low. Means this low RS value indicates that the resolution is very less. The two components are not very well separated. Okay, they are not separated from each other because this RS value is 0.5. Now see the second graph, which is having this second graph is having RS value 1. Here is also the two peaks are not separated from each other. This A component, this is the A component and this is the B component. This A component contains 4% of B and the B component contains 4% of A. Okay, means they are not totally separated from each other, but somehow they are separated. Only trace components of the A and B are present in each other. But when at the RS value 1.5, we get well separated peaks on the chromatogram. Okay, these peaks are totally separated from each other. These are the retention times of the TRA and TRB, means retention time of the A and retention time of the B. Retention time is obtained at the tip of this peak. Okay, at center point of this tip of the peak, from the detector response line we are plotting one line here and we get a TRA and TRB. Means this as the we can conclude that if RS is greater than 1 or RS is equal to 1, we get a separated band. But when we get RS is greater than 1, we get very well separated band from each other. The total separation will occur at RS is greater than 1. If RS is less than 1, we get a merge bands. Okay, the merge peaks are obtained at RS is less than 1. Now this resolution will increase with the length of the column. By lengthening the column, we can increase the efficiency of the column. This point we have studied in the plate theory. What we have studied, as number of the plates increases, efficiency increases. Now this point is explained from here. As number of the plate increases, efficiency increases means what? As number of the plates increases, the solute molecule have to travel in all these large number of plates. Therefore, large time will require for the elution. Means this our TRA and TRB value will increase. That's why the resolution will increase. As more time will require, this solute travel for more time in the column. That's why we get a well separated band. Means resolution is greater if the retention time is greater. When retention time will greater, if number of plates are increased, then we get large retention time for elution of the component. Therefore, resolution will increase and we get a complete separated band on the chromatogram. This is about the resolution in the chromatography. Resolution means separation of the peaks on the chromatogram, separation of the various components on the chromatogram, and this separation will increase with what? Number of the plates. This is all about resolution. Now we will start with the RF value. Now we will start with the RF value. RF means what? Retardation factor. Now this RF value means retardation factor. Now consider first one, TLC plate. Now if this is TLC plate, this is the baseline on the TLC plate. We apply the spots on this baseline. Now when we dip this TLC plate in the mobile phase, this is our mobile phase, our spotting should be above the mobile phase. Spotting should not dip in the mobile phase. Now what happens when we run this mobile phase on this TLC plate? This TLC plate is covered by the stationary phase such as the silica, and this liquid means the mobile phase. This spotting means our sample. We are spotting the sample on this stationary phase. Now when mobile phase run with the on the stationary phase, then what happens? There will be the components also travel with the mobile phase, and the separation takes place on the basis of the adsorption. Means the component which are having strong bonding with the stationary phase, they remains on the stationary phase, and the components which having the weak bonding with the stationary phase, they move with the mobile phase. On the basis of this principle, the separation will take place in the TLC. Now what happens here? If we get the first spot at this point, and if we get the second spot at this point, okay, this is what? Solvent front. Solvent front means what? The mobile phase will run up to this line. That is what? Solvent front. This is the first spot. This is second spot. Now what is this RF value? From baseline to the solvent front is what? Distance traveled by solvent, and from baseline to the first spot it is what? From here to here. This is distance traveled by first component, means distance traveled by solute. Distance traveled by solute. This is also up to this line. This one is also distance traveled by solute. Okay, this is the distance traveled by first spot, and this is the distance traveled by second spot. Now what is the RF value? RF value is distance traveled by solute divided by distance traveled by solvent, means what? Mobile phase. Now you have to remember, always distance traveled by solvent is greater than distance traveled by solute. Okay, now this will be the lower value and this will be the higher value, because always this solvent front will have the higher value than the solute. Then if RF value is 1, then what happens? Then our stationary phase will be immobile, means there will be no separation. The components will adsorb over the stationary phase. They are not traveling with the mobile phase. It is the immobile stationary phase. Okay, now when the RF value is greater than 1, then what happen? Then the all the components in the solute will transfer with the mobile phase. Therefore this RF value should be in between 0 to 1. What is the use of this RF value? RF value means retardation factor. Now there are many components having the fixed RS value. They are the standard value. In the experiment we are getting the RF value by this formula. The quantity we are getting, we are comparing that quantity with the standard value, and we can identify which component is present in the mixture. This is what? Retardation factor.